All right, welcome back to Precalculus. We are talking about inverse trig functions. This is going to be part 2. So let's go ahead and share. Okay, knock you down. And what are we doing? We just got done with this one. It's the last video. All right, so you can see there's quite a few of these. Okay, there's quite a few of these. So, screen sharing. I think I'm recording. Check. I am recording. All right. So tangent of theta is equal to negative 13/5. And we know that the angle is somewhere between 90 and 180. Okay. So what we're going to do, make a little note here. So we have the tangent of theta is equal to negative 13/5. And we know that 90 degrees theta, 180 degrees. So we know between 90 and 180 degrees, that's between here and there. So we know this is in the second quadrant. Okay, so this is in quadrant 2. All right, so when I go ahead and I take my inverse tangent, okay, so we're going to have theta is equal to arctangent of negative 13/5. Okay, we're going to get something in quadrant 4. Okay, am I still in degrees? Mode, degrees, I sure am. So we're going to get tangent, well, we're going to get inverse tangent, sorry. Second function, tangent, inverse tangent, not reciprocal, inverse tangent, negative 13 divided by 5. All right. And we ended up with about 68.96, so 69 degrees here. Equals negative 69 degrees. Where is that? That's down here, right? And we want it to be, right? We want it to be over there. Okay. So if I add 180 to this, we're going to get the appropriate angle. Okay. So what we're going to do is we're going to go ahead and add 180 here. Okay. And we got 111 degrees. All right, so that's what this is right here, is 111. Okay, so if we take our tangent of that, right, take tangent of 111 degrees, so just to check it, right, so we're going to take tangent of my previous answer. Okay, enter. And then we're going to, we can see it, right, that's 13.6. If you can't see that, that's okay. It's okay, you don't need to see that. We're going to go to math, we're going to go to frac, and we're going to go ahead and plug that in. And it changes a decimal to a fraction. Okay. Do not tell Sister Mary Agony that that's what I do now. She'll be livid. Okay. She's with us anymore, but she would not be happy that you can use a calculator to turn a degree, a fraction into a degrees. Okay, so here's what I warned you about, okay? Here's what we warned you about, that arc sine of a sine of 5 pi over 3, okay, this is not 5 pi over 3, okay? You can test it, okay? And say 5 pi over 3. It is not going to like that. Okay, see? So what we have to do is like, okay, what is the sine of 5 pi over 3? Where's 5 pi over 3? There's 1 pi over 3, 2 pi over 3. This is 3 pi over 3, isn't it? It's pi. The 3's cancel. 4 pi over 3, and then 5 pi over 3. I know these all look like they're 45-degree angles. They're not. Okay, they're just there because it helps me count around the clock to get there. Okay. So the sine of 5 pi over 3, right? We have to get a reference angle. How much more do I need to go? I need to go pi over 3. So what's the sine of pi over 3? Well, the sine of pi over 3 is square root of 3 over 2. What quadrant are we in? we are in the fourth quadrant, so that is going to give us a negative value. Okay, and yes, this is what you have to go through to get this answer correct. Okay. So we're going to say, okay, great. We have the sine of an angle gave us a ratio. We're going to do arc sine of a ratio to give us back an angle. Okay, so we're going to get, well, this, you know, if I think about this, right, what the sine of what angle is square root of 3 over 2? And that's pi over 3. But you need to put it in the first and fourth quadrant. But this is going to be a negative one, right? Because it goes this way. So that is going to be negative pi over 3. And I believe that is the answer they're going to want. Okay. So let's try again. We have negative pi over 3. All right, much happier. Okay, so again, just be aware of that. They are going to try to trick you there. Okay, don't get tricked. Okay, same, look at that. They're going to do it again. Say, we're not falling for it. You may have trapped me the first time. You have not trapped me the second time. Okay, so we have tangent inverse of tangent of 3 pi over 4. Okay, where is 3 pi over 4? It's here, right? We have 1 pi over 4, 2 pi over 4, it's pi over 2, and then this is 3 pi over 4. Okay, what's the reference angle? We have to go down one more, so that's going to be pi over 4, right? So what's the tangent of pi over 4? Tangent of pi over 4 is 1. Okay, so tangent pi over 4 is equal to 1. But where is it? It's in the second quadrant. So it's actually tangent 3 pi over 4 is equal to negative 1. Okay. Now we're going to do the arctangent of negative 1. That's going to give me, you know, something in the first and fourth quadrant, but really it's the first and like negative first quadrant. Okay. And we're going to get, well, whose tangent, right? When is tangent equal to 1? Well, we got a pi over 4 type of an angle. Okay, but it's going to be down here. So it's going to be negative pi over 4. Okay, negative pi over 4. Okay. So notice they didn't cancel each other out. This gives back this 3 pi over 4 business, right? We got a different answer. Okay, so there we go. Okay, find the exact value. Write your answer using a simplified fraction. Okay. Did they tell us where it was? They didn't tell us where it was. Oh, it's negative. Okay. So we want the sine of the inverse cosine of negative 1/2. Okay, so the important thing to remember, inverse cosine takes a ratio and turns it into an angle. Okay. Because I will try to mislead you. Okay. Because you could take the, you know, an angle or a ratio could be pi over 6, right? You could take the cosine of pi over 6. You could take the inverse cosine of pi over 6. They mean different things. So if I'm taking the cosine of this, that's an angle. But if I'm taking the inverse cosine of this, it was a ratio. Okay, it's less than 1, so it's okay. Okay? So double check, like, what am I taking? You know, what is in the parentheses? Is that a ratio or an angle? Okay, for the beginning ones, you know, it's fair that they look like ratios, but someday they're going to look like, what do you mean inverse cosine of pi over 6? You can't do that. Like, oh, sure you can. You know, just to quickly put it in, inverse cosine of pi over 6. Okay, 60 degrees ish. Okay. So don't think like just because it looks like something, that's what it is. Double check it. Make sure you know. Okay. What radians? Okay. All right. So inverse cosine, we think a ratio into an angle. So what is the rate? What is the angle? Cosine of what angle is going to be negative 1/2? Okay, well, there's a couple of them. It's going to be this one. Okay, we'll say that's, no, we won't. We will say that that's going to be pi over 3. Okay, pi over 3. Okay, here we go. All right, because cosine does this. So it starts up at 1 as we're going through the angles, right? Pi over 3, 60 degrees is going to be closer to the 0, 1. Okay, because pi over 2, so this is going to be 60 degrees. Right, or this is actually going to be 2 pi over 3, right? Okay, so we have a 2 pi over 3 here, okay? And we're going to take the sine of 2 pi over 3, and we're going to get square root of 3 over 2. Because again, reference angle here, pi over 3, okay? And the sine of pi over 3 is going to be square root of 3 over 2, okay? So let's see here. We're going to say the square root of 3 over 2. Okay, we're happy. Okay, all right. So there is a lot of this. Okay, I think I'm going to skip this one or two. Oh, perfect. Okay. So hold on for a second here. There we go. All right. So requirements for ADA. For a wheelchair ramp must have a slope of 1 to 12. Okay, so 1 foot of rise or drop for every 12 foot of run. Okay, so if you're going to explain this to a construction crew, that is one way to do it, but they're going to appreciate an angle. Okay, so we want the wheelchair ramp to be constructed with a maximum slope. What angle will that make? Okay, so we have a 1 foot rise for a 12-foot run. Okay, so there's my angle. We have our y over our x is equal to 1 over 12. See, 1 over 12. Opposite over adjacent. Do you know of which trig function will relate an angle to the opposite and the adjacent? Okay, we can arrange these as we need them. The tangent of the angle is going to be the opposite over the adjacent. Okay, so tangents are slopes. So the opposite is 1 over 12. We need to know what that angle is. So what we're going to do is we're going to say theta is equal to inverse tangent of 1 over 12. Okay, most of the word problems are really this straightforward. Okay, this is what they're asking you to do. We'll wait until chapter 5 to throw it off a cliff and hope that you don't survive. Okay, so we're just going to say inverse tangent, second function tangent, 1 over 12. And that's going to give us our angle. Okay, and is what mode are we? I think we're in degree mode. Okay, let's just double check. We are in degree mode. Okay, so about 5 degrees. Okay, 4.76 degrees. What do they want the answer to be in? Okay, so the angle we're going to be making is to the nearest tenth of a degree. So we're going to say 4.8 degrees. 4.8 degrees. All right, hooray. The ramp is 27 feet long. How much elevation should the ramp provide? Round to the nearest foot. Okay, there's a dozen ways to do this. Okay, but we know that this angle is what? This is 4.8 degrees. Okay, they said the ramp is 27 feet long, and they would like to know what is this. Okay, so we're going to say that the tangent of 4.8 degrees is equal to the opposite over the adjacent. We're going to say the opposite, solving for opposite, that's equal to 27 times tangent of 4.8 degrees. Okay, so all we're going to do is we're going to say, great, that is going to be 27. Come back here. 27 times the tangent. This is 1. 4.8 degrees, and hope for the best. Okay, 2.26, so I'm going to say there's going to be 2.3 height. Okay, 2.3 feet in height. Okay, back here. Okay, 27 times 4.8. Yes, there are other ways to do this. Yes, you are quite welcome to do them. Okay, so you don't have to have done it. You could have used this with algebra to do it, okay, and ratios, and that would have been fine. Okay, so find the ratio between 12 feet and 27 feet, and then multiply that by the top, and you would get the same answer. Okay, so there are other ways to go. All right, so 2.7 degrees, or 2.7 feet rather. All right, and there's 10th of a foot. Oh, they didn't like that. What did I do? 2.3, that's what I meant. Much better. All right. Student measures the length of a shadow to be 590 feet. A shadow, a statue. Okay, to be that. If the statue is 535 feet tall, approximate the angle elevation to the sun to the 10th of a degree. Okay, I will usually put in the instructions to draw me a picture. So let's go ahead and do a, okay, there's my statue. Okay, and we know this is what? This is going to be 535 feet tall. Okay, and this statue here, the shadow, is going to be 590 feet. Okay, and they want to know, like, what is this angle? Okay, what is the angle to the sun? Now, I did have a class that would do something like this, and here's the shadow, which is why I'm going to ask you to draw it from now on, because I'm not entirely sure what universe these people came from, but that's not how shadows work here. So, by here, I mean this universe. So I'm going to make you draw it. Okay, so you know where the shadow is. Okay, so do you know a trig function that relates the opposite to the adjacent? Oh, that was tangent. We just did this one. Okay, so tangent of an angle is equal to 535 over 590. Okay, and now how do we undo the tangent? The tangent is equal to the inverse, theta rather, is equal to the inverse tangent of 535 over 590. Okay, and there we go. Okay, so 535 divided by 590. So 42 point, that looks like 2 degrees. Check that, 42.2 degrees. 42.2 degrees. Okay, group of hikers, group of campers hike down a steep path. Okay. One member of the hike has an altimeter, so you can tell it to measure the altitude. If the path, so it's the diagonal, the path is 1,350 yards, but the altitude lost was 540 yards, what is the average angle of declination? Okay, so they want to know this one. So they want to know this angle. They know this side, right? The depth, the height rather, is 540 yards. And they know that the path length, okay, the hypotenuse, was 1,350. So if I look from the viewpoint of this angle, okay, it's 540 divided by, right, it's the opposite divided by the hypotenuse. So you have to think, what trig function will relate the opposite, the hypotenuse, and the angle? So what we're going to say is we're going to say sine of theta is equal to 540 over 1,350, because sine relates opposite over hypotenuse. Technically, cosecant does too, but we talked about cosecant, finding inverses of cosecant, and we don't want any part of that. Okay, so we're going to do theta is equal to the sine inverse of 540 over 1,350. Okay, so we're just going to type that into the calculator. Like, why do I seem not to care about the other angles in the other quadrants? Like, because we do a picture. Okay, so the angle of declination is going to be a positive angle. It's just not drawn in the just not drawn in standard form. Okay, so it's a little bit easier if you're not given like context for what the problem is doing. Okay, so this is 23 point. Okay, 20. Oh, where do I want my calculator? We want 23 point. What do they want? The average round to the nearest tenth of a degree. So that's going to be 23.6 degrees. All right. 23.6 degrees. I think I have asked the previous one with the staircase or the ramp for the stairs. I think I have asked that before in a quiz. Just thinking that if any of you are ever going to be like civil engineers or anything like that, I could see you doing a problem exactly like that someday. Okay. A city engineer, you have to actually figure that out. I could see you doing it. So snow tubing hill is 500 feet long, okay, with a 70-foot vertical drop. Okay, find the average the hill makes with the horizontal. Okay, round to the nearest degree. Actually, I think that's the same problem we just did. Okay, so I'm not gonna do that one either. They may have decided this is the horizontal distance, okay, versus the hypotenuse, but I think this is hypotenuse. So I think it's the problem we just did. So I'm not gonna do that one. Okay, so that should, and it really, I mean, as far as the word problems for this is about the difficulty you should expect, okay, for the word problems. For some of the other problems, okay, I could definitely see doing something like this, like as an A and a B kind of a setup. I would feel bad about doing an A, B, and a C kind of a setup because these take a little while to kind of sort out. But an A and a B, I could see it. Okay, so there might be a question A, B, right? With this one and that one, and then figure that out. Okay, if it's a word problem, I am going to tell you to draw me a picture. Okay, I've used the construction one before. I used the shadow one before too, but that ended in disaster. Mostly because they drew the shadow pointing from the statue to the sun. I think that works. So I could ask, I'm more partial to this one than the statue problem. Okay. But that's the kind of word problem I would, if I pick a word problem, this is the kind of thing I would ask. All right. So we'll call it there, and good luck with doing the homework. I hope this helps. All right. Thank you.